Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have discussed that we'll use our interrupt service routine to display the data on multiplex 7-segment display. We'll use 1 second time to increment the counter value, and we'll use 10 millisecond time to display the data on each digit. And we have 4 multiplex 7-segment display. And the anodes of these displays are connected with port D0. RD0 is the anode to display the data on unit digit. RD1 to display the data on 10th digit. RD2 to display the data on 100 digit. And RD3 to display the data on 1000 digit. And we'll use the port B, that is port B, to apply the data on 7-segment displays. In this session, we'll write a program to call an interrupt service routine of 1 millisecond and will display the data on multiplex 7-segment display. In our previous session, we have developed a hex table to display the numbers on 7-segment display. Here we have written the hex numbers to display the digits on 7-segment display. That is, for 0 we have written 3F. To display the digit 1 on 7-segment display, we have written the value that is 03. But there is a mistake in this conversion. Here we can find the number is 06 and we have written 03. So first we'll correct this number. And here we will write the number 6. Now we'll use the data 3F to display the number 0. The hex equivalent number is 06 to display the digit 1, 5B to display the number 2, 4F to display the number 3, 66 to display the number 4, 6G to display the number 5, 7D to display the number 6, 07 to display the number 7, 7F to display the number 8, and 6F to display the number 9. Now I'll write a program to display the counter value, that is from 0000 to 9999, and we'll use the time, that is 10 millisecond, to select each digit, and we'll use 1 second time to increment the counter value. Now we'll start writing our new program. We'll start our new program from new project. Here we'll go for new project, the standard project, and the project name will be Multiplex 7-segment display project, and the project folder will be in MikroC projects. We'll select the folder that is SSD project, OK, and the microcontroller is PIC16F877A. The device clock is 10 MHz. OK, next, finish. And here we have the main program starting from void main. First we'll write some assignments and comments. Here we have written the name of our project. Now we'll write some assignments. Here we'll write some bits assignments, that is, define test LED, port C3. Now we'll define the variables for anode selection. From the schematic we can see that the anode of unit digit is connected on port D0, anode of 10 digit is connected on port D1, anode of 100 digit is connected on port D2, and anode of 1000 digit is connected on RD3. So we'll define these variables in our program, and we'll write define anode underscore unit, that is port D not, define anode 10, port D1, define anode 100, port D 2, and define anode of 1000 digit, that is port D3, and now in main program we'll call our initialization routine. So we'll write initialization routine. So here we will call the initialization routine and we'll initialize the port directions and port values, and we'll also initialize different bits and registers to have interrupt of 1 millisecond in initialization routine. So here we will write the initialization routine, and here we will write ini underscore r, and we'll write the initialization routine between these two braces. So first in initialization routine, we'll set the direction of the ports that we will use in our program. So here I'll write that is trace B equals to 0. It means the direction of port B is set as output port, and here we'll assign comments. Port B is configured as output. As we have connected all 8 segments with port B using ULN2803, so here we have assigned the direction that is output to port B. Now we'll assign the direction to port D, that is trace D equals to 0. We'll add the comments. Now we'll assign the direction to the test LED, that is port C3 is configured as output. Now we'll initialize port B, port D and port C, that is port B equals to 0. It means that the value of port B is 0. All 8 ports of port B will be 0. Port D equals to 255. That is, all 8 ports of port D will be high. Now port C3. So here we have initialized the ports. Now we'll initialize the timer 0 register, that is TMR0 equals to 217. As we have calculated this value in our previous session to get the interrupt of 1 millisecond, and we have assigned the value to prescaler, that is 1:64. So here we will initialize the option register, that is option reg equals to 0B00000101. Here we can see we have calculated the value, that is 217 for timer 0, and we have selected a prescaler rate, that is 1:64, by assigning the value to option reg, that is the value of option reg is 05. So here we have assigned the value to option reg. Now we'll set 3 interlocking bit of intcon register, that is global interrupt enable underscore bit equals to 1. Peripheral interrupt enable, that is PEIE underscore bit equals to 1, and timer 0 interrupt enable bit will also be 1, that is T0IE underscore bit equals to 1. So here we have initialized the ports and bits that we will use in our program. And now in main program we'll write the while loop. So here we'll write the main program, Now we'll write the while loop. While 1, and we'll write the while loop between these two braces, and here we'll write port C3 equals to invert of port C3, and we'll call a delay of 500 millisecond, that is delay underscore millisecond 500. So in while loop we have written two instructions, that is to toggle port RC3 and a delay of 500 millisecond. Now we'll write the interrupt service routine, and we'll write the interrupt service routine before main program. So here we will write timer 0 interrupt service routine. Now here we'll write timer 0 interrupt service routine, and we'll write that is void interrupt, and we'll write the interrupt service routine between these two braces. First we'll check if the timer 0 interrupt flag will be set. So we'll write if T0 IF underscore bit is 1, so if timer 0 interrupt service routine bit will be 1, then our program will come into these two braces, and here we will reload the value of timer 0, that is TMR0 equals to 217, and we'll clear the value of timer 0 interrupt flag, and we'll write T0 IF underscore bit equals to 0. Now we'll write the program to display the counter value on multiplex 7 segment display. So here we will write, the 7 segment display program. Now we'll define two variables to have two delays, that is a delay of 10 millisecond for each digit and a delay of 1000 millisecond, that is 1 second for counter increment. So here we'll define variables, that is, here we'll write variable assignments. So we'll write unsigned character SSD delay equals to 0, unsigned integer, that is counter delay, equals to 0, as we have to count up to 1000 to have a delay of 1 second. Now we'll define another variable, that is counter, unsigned integer, that is counter, equals to 0. We'll display the value of this counter register on multiplex 7 segment display. Now here we'll write a structure, that is case structure, to assign the hex value to the numbers. So we'll write 7 segment conversion structure, and we'll write unsigned int hex, that is integer SST, that is 7 segment table, and here we'll write the case structure between these two braces, and here we'll add comments, that is 7 segment table, and here we'll write, that is switch SST 7 segment table, now we'll write case 0, that is case 0 return, and return value will be Here we can find to display the number 0, the return value will be 3f. So we'll use this hex table in our program. 0x3f, case 1. And return value will be 0x06. So here we have written all 9 cases. That is, to display the value 0 on 7-segment display, we'll pass on the value on port B, that is 3f. To display the value 1, the value will be 06. For 2, the value will be 5p. For 3, the value will be 4f. To display the value 4, the value will be 66. To display the value 5, the value will be 60. For 6, the value will be 7d. For 7, the value will be 7. For 8, the value will be 7f. And for 9, the value will be 6f as hex. And here we can find that we have calculated these values in our previous session.